Welcome to 360 degree TMG and welcome back to the interview preparation session also. So let's begin. Okay, we'll go with some random questions here. So first to begin with, how do you treat heteroskedasticity? Okay, in regression, how do the treatment should be given if at all we come across heteroskedasticity problem in regression? So we all know that heteroskedasticity means we have some unequal scattered distribution. So in regression analysis, we generally talk about this particular problem uh, when when the context is something like error terms. So it is nothing but kind of, we can say that a systematic change in the spread of the residuals or errors uh, over some range, right? And that range we have the measured values. So it is only, we can say that this is a problem because of ordinary least squares, right? And OLS regression, that all the residuals which are drawn from a random population will have a constant variance, right? When we say constant variance, right? If at all you're doing a plot, it could be something like this. So a person with this X and a person with this X. See the variance here. Suppose if you have the best fit line to be the green line here, this value, see the error term and see the error term here. A different value of X. Right? So we say that if at all you are scatter something like this, then definitely we are into this particular problem. Actually, what is the reason? What is the cause of this heteroskedasticity? Right? That should be addressed first. Then you will say, how do you treat that? So this occurs more often where we have large range, right, between your largest number and the smallest observed values. So there are many reasons why this heteroskedasticity can exist, and the normal explanation, or we can say that a general explanation, it could be like, we can say that it's the error variance, it changes the proportionality with a factor. Right? Again, when we talk about this heteroskedasticity, generally we can categorize as pure heteroskedasticity and impure. So when we say that it is a pure heteroskedasticity, so it refers to the cases where we specify the correct model and we let us observe the non-constant variance, right? We have to observe the non-constant variance when we do our residual plots. So we have to observe that non-constant variance in the residual plots. When you talk about impure heteroskedasticity, it refers to the cases where we are not correctly specifying the model, and that is leading to non-constant variance. It's something that you are leaving something, some variable which is very very important, right? You are leaving an important variable out of the model, and the omitted effect is absorbed into the error term. If the effect of this omitted variable varies, throughout your the observed values, the range of data, right? It can produce us the our telltale signs of heteroscedasty in the plot. That is our residual plots. Now you have to explain how you are going to fix that particular problem of heteroscedasticity. Maybe you redefine the variables, and if at all you are we are working with a cross-sectional model that includes, definitely there will be large differences between the sizes of the observations. You can find different ways to specify the model that reduces this impact of whatever you're talking as a size, maximum, minimum values, the range. Because of that, the size differential has to be reduced. The impact of that size differential has to be reduced. So to do this, what you have to do, you have to just change the model from using the raw measures. You have to change your model here. So whenever you talk about this type of models, it's you need to determine whether the approach, whatever you are taking or call, it is suitable for both your data and what is your main objective there. What you need to learn is also should be focused. And weighted regression, right? It is a method that where you assign every data point, right, each data point to a weight based on the variance of its fitted value. So the idea is to give small weights to the observations which are associated with high variances to shrink their squared residuals. So this particular weighted regression, it minimizes the sum of the weighted squared residuals. So when you use the correct weights, what happens is that whatever we are trying to fix, the problem of heteroscedasticity, it would be replaced by homoscedasticity. This is how you have to go step by step. What is actually it is, what are the types you have, and how do you fix your problem. And when we are talking about regression, we have one more problem, right? One more problem is, these are all should be satisfied, right? What is multicollinearity? Right? What is multicollinearity? Now, the same thing, how do you treat it? Yeah. What should be your approach to solve this problem of multicollinearity? So generally, when we say multicollinear, the term here, it means that independent variables are highly correlated to each other. So when we are working with regression or we are into regression analysis, it is an important assumption that regression models should not be faced with the problem. The so-called problem what we are talking is a multicollinearity problem. Suppose you have two variables and they're highly correlated, right? It's very tough for us. It's very hard to tell which affects a dependent variable, right? Because you have your y, x1, x2. This is your dependent, and it's very tough which is affecting. So y is regressed against x1 and x2. Assume that x1 and x2 are highly correlated. So the effect of x1 on y is hard to distinguish from the effect of x2 on y, because any increase you observe, right? Any increase in x1 it tends to be associated with increase in x2 also. Right? It is nothing but this is one way you just try to check it out. Another way you look at this multicollinearity problem is individual t test, right? Individual t test values, which will give you your p values, right? Which this is nothing but this t with the t whatever p value you are getting, it is maybe it could be something misleading. Whatever is our requirement, it's not up to the mark, right? It means the p value can be high, which means that if this value, we all know that if it is greater than 0.05, whether it is x1 or x2, these are not important for us, right? Which means the variable is not important. But even though that variable is important, right? That is one thing. That is how you check whether your model is having it did not satisfy the assumption of that multicollinearity. There's some problem with the variables, that is independent variables. Now, how do you correct this particular problem? One and easy way is that we try to remove, which is the last option for us. We never try to remove any of the columns because we know the how much important and how much time and how much efforts we put to collect the data. So if you remove one of the highly correlated independent variable from the model, okay, if you have two or more factors with a high VIF, that is variance inflation factor, so you remove one of them. You remove one out of what we're talking as x1 and x2. Otherwise, we have a very famous algorithm, right? Principal component analysis, right? So we all know that if you are applying a PCA to the data, it will cut the number of interdependent variables to a smaller set of uncorrelated components. If you remember, whatever PCs are there, though your data is correlated, pieces would always remain uncorrelated. Right? Instead of using highly correlated variables, use the components in the model where you have the uncorrelated components, right? And one more option you can, it's like ridge regression. So it is a technique for analyzing multiple regression data that will suffer from multicollinearity problem. This is one more solution, right? And also we try to find out something like we call the term as interaction term, right? So if you include an interaction term, you can also reduce the multicollinearity by centering the variables. So by centering means you just try to, it means that subtracting the mean from the values of the independent variable before you are creating the values. What is that intermediate effect of one variable? That also, if you capture, you can solve the problem of multicollinearity. Now the question comes, when this is not a problem for us? When is multicollinearity not a problem? Let me write it down. When it is not a problem for us. What is our goal actually? Our goal is to predict y. And we have y from a set of x variables. Your goal is to predict your y. So the predictions will be accurate, right? Sometimes, if at all, the overall R square or adjusted R square value will quantify how well the model is predicting your y values. And one more case where you have, multiple dummy variables, right? Multiple dummy variables are, where you have a categorical variable with three or more categories. At that time, this collinearity problem is not at all a big problem for us. It's not a problem only. When you use that term while answering this question, the second one, VIF, definitely the next follow-up question would be when and why you use this VIF. Right? Variation, or let me write it down. Right? So why and when to use this. When and why to use this. So it provides an index. What is that? What does that actually measure? It will measure how much the variance. So when we say variance, it is nothing but the square of the estimates standard deviation. Right? So how much the variance of an estimated regression coefficient is increased because of collinearity. Right? That is what it measures, VIF. So how do you calculate VIF? VIF is nothing but you are calculating using your R square. 1 by 1 minus R square. If I say R square is calculated for jth variable, some variable, 1 by 1 minus R square, where R square of the jth variable, what do you call this as? Coefficient of determination. Right? It is coefficient of determination. Okay, that also of the model, this determination R square is of the model that includes all the independent variables except your jth predictor. Now you know predictors are nothing but your inputs. Target is your output y. Right? VIF by 1 minus R square of the jth variable. Right? Now what is this R square? Where R square of the jth variable is nothing but the multiple R square for the regression of xj. Right? If you talk about Rj, we have xj. Right? R square is nothing but the multiple R square value for the regression of xj on the other independent variables. Right? A regression that does not involve the dependent variable y. You are not involving your y here. If at all your value is greater than 10, few textbooks even say it's 5, 7, but if it is crossing that particular 10 value, then there is a problem with multicollinearity. We have this problem coming into picture. Suppose if this VIF, whatever you're talking, is equal to 5 or 10, this means that the variance for the coefficient of that particular predictor variable, right? Let me write if it is a 10. So the variance, whatever we are considering for the coefficient of that particular predictor variable of your input is 10 times as large as it would be, right, if that particular xj were uncorrelated with other predicted variables. It's nothing but if VIF is 5 or 10, this means that the standard error for the coefficient of the predicted variable is square root of 5. If we have taken 10 here, so it could be 10. 10 root 10 times as large as it would be if that particular predictive variable were uncorrelated with other input variables. This is the interpretation. If the particular value is 10 or 5, if it is root 5, if it is root 10, it will be root 5. Right? So when we are talking about collinearity, correlation, and all this, now what is this correlation and covariance in statistics? How will you explain correlation and covariance? So what is correlation and covariance? Statistics. So there are two math concepts, right? These two approaches are very widely used in stats. Right? So whenever you are talking about correlation and covariance, both, they establish a relationship and also the measure, whatever the measures we calculate, right? It talks about the dependency between the two input random variables, or it is between your input and the output variable, right? Whatever they help us to get some information or get some insight, the work is similar. But when we talk about the formulae or the calculations, there you find some difference here. They both do the same job here. And so how, for correlation formula, we use covariance, right? So like we have the correlation coefficient, what we say. So it's a technique that can show whether how strongly the pair variables are related. So if you use COV here, covariance, Rx and Ry by your sigma x and sigma y. This will give you your correlation coefficient. Should textbooks write also this symbol. Right? So how strongly the pairs of the variables are related. For example, if we say height and weight, right? So usually when we talk taller people, they tend to be heavier. For example, just like for example, say if tall people they are heavier than short, so the relationship is imperfect. People of the same height may vary in weight, right? People like 5 feet, 5 feet 1, 5.2, like that, they may vary in weight, right? You can easily think of two people, where the shorter one is heavier than the taller one also. So the average weight of the people, if you take any number like 5 feet 5 inches, is less than the average weight of the people who are 5.6. Right? And you can also say that their average weight is less than that of 5.7 inches, or average weight is less than that of 5.4. It continues, etc. So correlation can tell you just how much the variation in the people's weights is related to their heights. Right? How much is the variation in people's weight, right, is related to their height. When it comes to covariance, it would measure what we say, the directional relationship between the returns on the two assets here. Right? So if it is positive, it means that both the assets, the return, they move together. Negative covariance means they move inversely. So covariance is calculated by analyzing It return surprises is nothing but standard deviations from the expected return, or by multiplying the correlation between two variables by the standard deviation of each variable, right? Each variable. So if at all you are talking about here the formula, right? So how we can write the formula for this? For covariance of x comma y, which is nothing but we write xi minus x bar, right? You are multiplying it with yi minus y bar. Now y bar and x bar are the averages by n. If we are talking about population, it is n. If you are talking about sample, same xi minus x bar yi minus y bar by n minus 1, right? So when we are talking about correlation, right, correlation coefficients, right? This is correlation and covariance. Now what is correlation coefficient here, which is determined by, which is represented by small r, right? So it is it is a measure, right? And let me write it down. Yeah. So it's a measure that calculates the strength of the relationship between the two variables. Right? We use it to measure both the strength, the direction of a linear relationship between two variables, right? Where it is represented with your small r, and this small r range is from -1 to 1, right? A calculated number greater than 1 or less than -1 means that there was an error in the measurement. If something which is less than 1 and greater than 1, if you calculate this, there's an error. It did not measure correctly, right? Like a correlation of -1, it is nothing but a perfect negative correlation. If it is plus, it is a perfect positive correlation, right? So we are using this particular formula here to find out how strong a relationship is between two variables, right? Where one strong positive relationship, -1 strong negative relationship, right? Like usually standard is at 0.85. R is greater than 0.85. It is good enough to move forward, taking that particular variable into consideration, as it has good impact on you. There's a good relationship between the two variables, whether it is input and input, or it is output and input, right? So for every, when we say that the correlation coefficient is 1, right, r being 1, what is the interpretation of that? It means that for every positive increase in one variable, there's a positive increase in a fixed proportion in the other, right? It's nothing but you have shoe sizes is increasing, right? Because our foot length is also increasing. There's a perfect correlation, right? Foot length is increasing, shoe size also goes up. When you talk about correlation coefficient of R, which is being equal to -1, it means that for every positive increase in one variable, there is a negative decrease of a fixed proportion in the other. So what example we can take here? The gas content, the amount of gas in a tank, right? So the gas is decreasing, and almost decreasing with speed, right? That could be an example for this. Now what if we have this value being 0, right? If it is 0, so 0 means for every increase, it is neither positive nor negative. They are just not having any relationship, right? So negative correlation is a relationship between two variables. It means that if one variable is increasing, the other variable is decreasing. It's vice versa, whatever it is. X and Y you are talking, one is increasing, the other is decreasing. Right? You can also say that it is, the other name you can give it as inverse correlation. Right? You call it as inverse correlation. It's a relationship between two variables where both are moving in opposite directions. Right? Similarly, positive is also same way, in which both the variables, they are moving in hand. If one is decreasing, the other is also decreasing. If one is increasing, the other is also increasing. So if at all you try to draw the, like try to find out through graph, if at all are near to your line, you can say that you are having r equal to 1. Good relationship. If you do a plot, right? Suppose you have little bit here and there, very less. Right? Same y-axis, same x-axis. You have r being 0.85. Right? What if you have 0.3, worst scenario? This is the worst scenario. And finally, what we expect for x and x, right? This is what we want, right, for x and x. Now, same thing, it would be like this for this. Negative side, r equal to minus 0.85. Here is for r equal to minus 1. Right? Now, this is what is about the correlation coefficient. So it helps us to determine the strength, the relationship between two variables and other types. Now, what is a model parameter? What is how will you explain this? What is it actually? You can make it, yeah. So it is a configuration variable that is internal to a model and whose values can be predicted from the data. So whatever values you want to predict from the data, that is nothing but model parameter. Definitely we require them while we are making predictions, right? So it is estimated or it is learned from the data, and it is often not set by the person who is using the model, and it is often saved as a part of the learned model. And the value, whatever we are defining, the value, the more parameter what we define, it is a skill of the model and how it is assigned. So parameters are the key. And we say that these are the keys to your ML algorithms. So these are they display a very important role, or these are the part of the model. I can say that is what are they learning from the historical training data. Okay? Those are nothing but your model parameters. Now, the follow-up question would be, if these are the model parameters, and what is model hyperparameters? What are these hyperparameters all about? Here, we don't have any control. We need not specify few things here, right? But when you talk about hyperparameter, right, we know something called as hyperparameter tuning. That is external to the model and whose values cannot be estimated from the data. You can't do any estimation from the data here, right? It is used in the processes to help estimate model parameters. So the practitioner often specifies them, right? It is tuned for any given predictive modeling problems. And we never know what is the best value here, right? For any given problem, how can you judge yourself that this is the best parameter and you are going to get a very good result for this particular parameter, right? Sometimes what we do, we use the thumb rules here, right? We try to use whatever the parameters you have set for any different problem statement that worked well, that particular problem. Maybe there's a chance that it would work well for this problem also, right? It's just like we are spending time here for trial and by trial and error methods, right? So if at all we can just specify, like, the differences here. If at all I write these are the model parameters, right? Or whatever we have, like, the weights, I write some equation here, xij wj, right? So I will have w naught, I will have w1, w2, wm. These are nothing but my model parameters, right? What about my hyperparameters here? Right? These are my hyperparameters. So I will have n iterations. I have my gamma values. I have CV. I have alpha. Right? I have random underscore state. Right? Maximum underscore depth. Right? Kernels. Right? Test size. All these I can change the CV. N folds. I already written this. Right? N folds. These are your hyperparameters. Right. So when we are talking about this model hyperparameters, now the most important parameter what we always try to use, a technique what we use mostly is cross validation. What is cross validation? It's a parameter, hyperparameter, right? So it's a technique for evaluating your machine learning models by training the model on several subsets of the available data. I can say that several subsets of available input data, and you are evaluating them on the complementary subset of data. So you use cross validation, right? Maybe to detect the overfitting problem, because that is nothing but you're trying to, whatever the failure happened, overfitting problem that is. We are unable to generalize any pattern there, right? So what happens actually when we talk about cross-validation techniques? What will we do? First, we'll reserve some portion of data, some portion of sample data set, right? So that particular sample data set is somewhere there. Now using the rest of the data set, you train the model. So you test the model using the reserved portion of the data set. So these are the steps what you follow when you are going for this. So it depends upon how many folds you want to do that, because you have several ways to apply this particular technique of cross validation, right? So first, if at all you're talking about the iteration, what happens? You have to run this for k iterations or number of iterations you want to give the, you want to make your model learn from the data, right? So you do partition of the data whatever you have taken, right? So for the iteration 1, if this becomes my test, all the rest of the data would become my trained data. When it comes to iteration 2, okay, this data is left out and next set of data, this would become my test data. When it comes to third, all this is here only, right? This portion would become my test data. It depends upon how many sets it has made, right? Finally, if it is fourth iteration, everything is my normal data. This becomes my test data here. So this is when it completes all the iterations, training is given on all the data so that you will solve the problem of overfitting. Right? So this is what happens in cross validation. It's important that we have many techniques, we follow many techniques here. Right? So how do you do that? Valid methods of cross validation also you have, like you have leave one out of cross validation, right? You have leave one out cross validation, right? We have k fold CV, right? So leave one out cross validation, and this mostly widely used. So whatever we are doing in leave one out cross validation, we perform training on the whole data set, but leaves only one data point, leave that particular one data point of the available data set, and it iterates for each data point. So definitely it has its own advantages and disadvantages. We know that, because how much time? An advantage is that you are making use of all the data points. So there is a something like, it could be low bias situation, what is expected. But what is the major drawback here? If that particular data point is an outlier, it will lead to high variation. And also the one which is for, if at all you're having 10,000, for that at least 10,000 data points only, how much time it should take, the execution time here, because it has to iterate over number of data points, 10,000 number of data points it has to iterate, right? So that is leave one out CV. What happens in k-fold CV here? When you're talking about k-fold CV, we split that particular data into k folds, into k number of subsets. This k number of subsets are also called as folds. And then we perform training on all the subsets, but leaving only one, that is k minus 1 subset of evaluation of the trained model. So how many times we iterate? We iterate k times with different subset reserved for testing purpose each time. Right? So every time, just now as I showed you, this becomes test data. If at all it is divided into 5 folds or 4 folds, 1, 2, 3, 4, 5. One time this becomes test, then this becomes test, third time, fourth time, fifth time. And you will have number of instances. What is the value of k? What is the number of iterations? Right? So what will be the advantages here? Definitely your accuracy would increase, because each and every observation you are training it and you're also testing it. More accurate estimate of your, what we say, that out of sample accuracy. Right? This is the advantage of cross validation techniques. So when we are anyway talking about this cross validation, what is the difference between a validation set of data and test set? Both are same. Explain the differences between a test set and a validation set. Both are same. We have to know that, right? We have understood cross validation, but what is this validation set and test set is? So validation set, it can be considered as a part of the training set, right? As it is used for parameter selection, and the main purpose here is to avoid overfitting of the model being built. Whereas when you talk about test set, it is normal, right? It is used for your testing, or you are trying to evaluate the performance of the model, whatever you have built. So simply, if you want to summarize the differences, right? So training set is used to fit the parameters. We have studied about the parameters also, right? So training set is used to fit the parameters. Maybe we can talk about the weights. Test set is to assess the performance of the model, right? And here you have the validation data, right? This is my train, this is my validation data. Here, this is used to tune your parameters, right? You divide your data into 3 parts. So you tune your parameters, whichever parameter is giving you the best, is it performance wise or accuracy wise, you take that parameters and go for testing on the test data, right? And also we have many things like what tuning parameters we are doing. Make a note of all that. And for when you're applying tuning parameters also, if at all you're applying k-fold, right? So what happens? It becomes more and more the best of the best model there, right? Okay. Now, so let's take a different set of questions here. What is data wrangling? How do you explain that? What is this process all about? Data wrangling. So we spend so much of time here as a part of this process, right? So it's a process by which we convert and we try to prepare the data, or we can say map the data. So we are trying to do some changes to the data from the raw form, right, to a format where it makes more valuable for our analysis. So that is one thing what we can do here. And when we are trying in this process, right, so this could be the very first process here, whether it is machine learning or whether it is deep learning. This is the first step, right? So what is the goal of this particular process here? It is to provide data that is uh, actionable and to provide it as fast as possible. You have to make the changes. All the pre-processing things should be done as quick as possible so that you will uh, start your model building, right? Suppose as a part of this, you do many things, right? You go for missing value imputation, where techniques you handle the duplicates, you do a kind of normalization or standardization, you do what is that discretization of the data, right? You calculated the variance in the data, right? Many things are a part of this. You have to even detect outliers, right? So if we are giving the list of all this as a part of wrangling, what happens? The next question would be, okay, then how do you evaluate that the data does not have outliers? How do you evaluate that? So we know that as a part of pre-processing, this is the outlier concept is where we spend a lot of time, right? Outlier is where we spend a lot of time. They are the data points that don't belong to a certain population. We also call it as an abnormal observation, right? That lies far away from your other values. So it is nothing but we call it as like it's an observation. That will diverge from the well structured data. Now, how do you do the detection of that? Right? First thing is that how do you do the detection of that? So there are many ways, and we have formal ways, exclusive ways here for detection. First method is that if at all you're talking about the method one, right? It is a standard deviation, first method, right? So in statistics, if the data distribution is approximately normal, then about 68% of the data values lies within our one standard deviation of the mean, right? If at all you try to draw and just normal distributed curve, if this is your 0, this is your -1, -2, -3, this is 1, 2, 3. So this, okay, so this region is 68, right? The next would be 95 and the next is 99.7%. So if the data distribution is approximately normal, the data lies within one standard deviation of the mean. 95%, about 95%, they are within two standard deviations, and about 99.7%, they lie within three standard deviations. So if at all you have any data point that is more than 3 times the standard deviation, then those points are likely to be outliers. This is the first way you can conclude it. Second way is that our very famous box plot. So this box plot, these are nothing but a graphical representation of the numerical data where it takes the process of doing quantiles. So you have outliers, you have the whiskers, you have the box region, and this. It could be upper whisker. This is your, if you're taking in this way, this is your 75th percentile. This is your 25th percentile. This is your median, right? So lower extreme value, upper extreme value, these two are your whiskers. And we also know that if at all Q1 minus 1.5 into your IQR, Q3 plus 1.5 into IQR, right? This is your IQR region. Anything which is less than this and greater than this is treated as outliers, right? So it's very, very simple but effective way to visualize the outliers, taking lower whisker, upper whiskers as the boundaries of the data distribution. Any data points that show above or below this whiskers, you treat them as outliers. There's one more plot which will help us to detect, that is violin plot, right? So these are very, very similar, but it just looks like a violin kind of thing like this, right? Just somehow it looks like. So very similar to box plot. They show the probability density of the data at different values, right? So this violin plot will include all the data that is in a box plot, right? And you have a marker, this one, for the median of the data, like a box or a marker indicating the interquartile range, right? And possibly all the sample points if the number of samples are not too high, right? This could be what you say, the this line could be different like this, right? Sometimes it's a kind, it gives you an idea of how many outliers are there, but box plot is what we always prefer, right? And one more plot, scatter plot, right? Scatter plot also will help us to identify if there are any outliers, because we have all these options, we have to mention all these options. So scatter plot is a type of plot where you do a plot for two different variables, right? And the plot will help us to find out very few, like if you can draw like this, if all the data is concentrated here, we have one or the other which are very, very away from the entire data, right? The value of other variables determine the position on the vertical axis, and you have y and x, any variable you can take. So they're very, very far away from the general spread of the data. So they have very few neighbors. So there is a chance that they could be treated as outliers, right? So to evaluate, you will go for box plot. You check your standard deviation. You check your with using your violin plot and also your scatter plot. It gives you an idea, right? So this is the first thing what we focus when we start our data wrangling process, right? So, okay, thank you all for joining the session. So you can continue with the next career guidance session here. Thank you all.
Good evening, everybody. Uh, you've just heard my colleague. He has given you some tips with reference to the interview preparedness and various important questions that are generally asked. And now I'm going to be talking predominantly in the space of resume preparation and how we can work out on our resume in such a way that our chances of our resume getting picked up, massively increases. So that is what we are going to be working on. All right. So let's continue. So first and foremost, it is not just the resume that is going to help you with getting the or taking you to the next level. There are multiple things that one needs to take into consideration. So we will address all of them. So resume is one among them, the channels with which the person gets hired. There are multiple things, and I cannot stress enough about the importance of these various channels. Okay, so okay, so let me just continue. So the basic various channels that we have are the importance of resume, social media, LinkedIn, GitHub, types of interviews, do's and don'ts, all these things. We will look into it. So one of the most important hiring channels are, okay, the LinkedIn, social media, employer referral, and personal network. Now, the importance of various things, these are the most important aspects that are there. Over and above that, we have also something what is known as, sourcing firms, referrals, pipelining, etc. These are, of course, information that we have pulled out from various locations. All right. And now moving along, how to get calls from recruiters. Now, resume is one among them, and resume building sessions, we have conducted a lot of resume building sessions. What is the most important aspect to improve your chances is to have a multi-pronged strategy whereby you can have, um, from different sides you can attack and get the chances of your resume being picked up. So if somebody is seeing your LinkedIn profile, people approach on your LinkedIn profile based on your this thing. Okay, your when your resume gets picked up, they look for important keywords. They look for GitHub repository. They look for whether you have worked, given some responses, or you have been a contributor to Quora. Kaggle rankings are simply amazing. They are very, very, what shall I say, elite um, um, thing. Not everybody can, get a big amount of rank, but if you are capable of getting a big rank, then you will definitely all right, then it is better to do that if you can do it. And then of course your presence on Facebook. All right, on most of the social media, what is your presence on Facebook, etc. So now most importantly, obviously the resume is important. All right, and the latest fad is the double column one-page resume. All right, now I think it's the concept of resume is predominantly in the perspective of printouts. People make the resume in such a way that they expect the person to take a printout of it and put it in a file, which is not the case. Resumes are no longer being printed. All right, nobody is sending out a resume. Nobody is going to an office, standing at the door, and giving their resume a hard copy. That's gone. So when that concept is gone, why is the format of the resume still something wherein you have to print out and do things like that? So given this background, you may want to ensure that you use up, you give more content, and you can try to do that. And if there is more content, and if people have to zoom in on the PDF document to look at your thing, or maybe scroll up and down, is also perfectly acceptable. Printing is culturally a no. As far as possible, avoid printing. All right, so that is one thing that you must remember. Junk the thing if people look at it in the perspective of printouts. So forget that. You don't have to give your resume. The format need not be a A4 or a legal. It can be much bigger than that. You just need to convert it to a PDF. Right. Now, what is the content that you put inside your resume? Okay. I think I have had experience with multiple HR professionals whom we contact for the purpose of getting our students, our participants to do them. And one of the common things that I have learned from most of them is they are now experts in spotting something that is fake. So please be very honest, brutally honest if you have to be, in your resume, and be very clear what you know. Mention only what you know. Do not mention things that you just read the title and you're hoping to pass on that. So that is something they have. The HR people have their checks and balances to ensure that you are whether you are faking in your resume or not. Now that is a problem, right? Because people who are freshers, people who are just out of college, or maybe were out of college and have been working in probably doing a training program in data science, artificial intelligence, etc. And after that, they have decided to join the program. For them, it is going to be a little difficult to show what experience and nothing like that. Tell them you are a fresh. All right. Tell them you passed out in 2021. You're passing out in 2021 June, or you passed out in 2020 June, and you can clearly mention you spent your time in doing a program. You can spend your time in working on various projects that were offered by the institution. And if you are with the 360 digit MG, you can definitely uh, if you're with 360 digit MG, you can definitely uh, have an opportunity to work as an intern with Datatics. That is an option that we have. So those projects, all those things you can mention. And obviously your contribution in the project should be exemplary. So like I said from the beginning, you cannot fake your way into the what shall I say, you cannot simply fake your way into the uh, through your resume or this thing, and you say, no, I did this project, I did this project. All right. And then obviously there are people, the technical people, who will grill you on that particular project, and they'll know what was your exact contribution. So please be very clear about the general project what you have done, and a little detail about what you have contributed in the project. Now, for a fresher, it's okay to mention training details. For a person who's experienced, it is not advisable, because if you have had some experience, let us say a year, 2 or 3 years of experience in any domain, then mentioning that you were part of a training institute and you kind of took a break in career and 6 months you were doing that is definitely looked down upon. It look sometimes many organizations look at it as a kind of lack of success or some kind of failure. So that is one thing. And If you're mentioning a POC, proof of concept in a project, then ensure that you mention this was a POC and this was something that we have done. All right. Now, how do you explain a project in the interview? Okay. So it is important to everybody understands that when you do a project, when you do a task in the analytics space, it is never going to be a smooth ride. It's not going to be a walk in the park, right? You will definitely face certain challenges and issues, and you will take 2 steps forward, 3 steps back, 2 steps forward, 3 steps back. All these things will happen. And if you have not faced those things, it is very clear that you've probably faked in your resume. So what you need to do is you need to explain definitely in your project, in the interview, I did this, then I did this, then I did this, then we did this, and this was the end. No, this is not acceptable. The project was explained to us. We had a discussion, we had an initial kickoff meeting with the concerned people, and they told us. But immediately afterwards, when we wanted the data, the biggest problem is going to be with data. So the biggest problem when we wanted data, it was not relevant, and therefore we had to do a lot of work to get the data. And then when we got the data, it was having some problems, so we had to do a lot of munging and all those things. These things we had to do, and ultimately we could manage to um, do that. And it just took a lot of steps, and we decided to probably simulate the data or things like that. So these are some of the things that if you mention, you may be able to be able to understand, or you'll be able to get some brownie points from the interviewer that all right, brownie points from the interviewer that you actually worked on the project. And of course explain about the EDA, because EDA in real life is going to be uh, walking on hot coal. You might have seen that. I mean, doing EDA is not easy. EDA, if you don't have any anecdote or any story to tell in the EDA, I definitely, if you are coming for interview to me, and when you explain the project and what all did you do in EDA, we did this, we did this, we did this. I mean, you simply give me a textbook answer, I'll simply reject you, knowing pretty well that you have kind of faked your experience as far as the project is concerned, because no EDA in real life is that simple. It is terribly difficult. Need not stress too much about the model building, model validation and iteration. Of course, that is there, and obviously, ultimately, what is the benefits, tangibles and intangibles both, if possible, you can probably mention. That is what you'll have to start off. So have a story ready in your mind, all right, and it is always, there is an expression. So when you are at when you are in a fight, or when you are in a fight with somebody, choose your battleground. All right, choose your weapons and choose your battleground. So basically, attending an interview, you are at a disadvantage because you don't know what questions the interviewer is going to ask. But the advantage you have is how to lead him or her into your path. So leave out information which you are sure the person will catch, and try to ask more questions, and probably ask and explain. So if you are uh, very confident about a particular topic, explain it in limited detail, and kind of pretend that you know only that much. And then when the person decides to ask you, can you explain a little more, then you explain a little more about it. So that is definitely going to give you brownie points. If you immediately, when you get a easy question or a question that you are very well versed, and when you start telling in detail, trust me, the interviewer is going to say that so much detail is not required, stop it. So he is going to try and find a question which is not known to you. So you've lost an opportunity, and that's one thing that you may want to remember. That is where I meant by uh, taking the battle to your home area so that you have a home advantage. And if your LinkedIn profile is not updated, if your LinkedIn profile you don't, if it is not there, and then you are already not interacting on your LinkedIn profile, then it is you're already pretty late. All right, you're already pretty late. Uh, from the time you create a LinkedIn profile till it matures, you will need 6 months, minimum of 6 months, sometimes even a year, before you can start, just reaping the benefits. So from the time you decide, okay, you know what, I'm going to become, I'm moving into data science, and now I need to get a job. From that day onwards, you create your LinkedIn profile, start connecting with people who are relevant. Be choosy about your networking. Don't connect to people left, right, and center, and make it another social media or entertainment kind of a thing, wherein you are following and liking cat videos and political discussions and religious threads. All these things are, a little something that you may seriously avoid, because no organization prefers a person who's a little bit of a radical. All right. So if you have strong opinions about the ruling party, or if you have strong opinions about a specific religion, and then you are following or you have a strong opinion about anything, the HR persons are going to be a little careful and may want to uh, you know keep you in the last, if even if you're a good candidate. I have seen this happen. All right. Therefore, it is something that I'm advising you as well. All right. Obviously, if you want to show that you are serious about your career, then participate in the discussion threads. All right. If somebody mentions something, one of the standard things, I am a trainer as well, and when I communicate in the class to create LinkedIn, please connect with me, etc. What happens is they simply start liking the post that I post, and if you look into their profile, they will find out that they have liked some 50, 60 posts, not a single comment, or at some extent they'll say like and also share, but they will not make their original comment. Now if you're going to share something, share it with some note in the beginning. If you're commenting on something, all right, some person's thread, somebody has this thing, amazing article, thank you so much for sharing. It is, I mean, apart from that, apart from thank you so much for sharing, you may want to write 2 3 lines more. All right. Suppose recently I saw an article of a person who had explained about of course, I was just reading through the thread, and he was more like a competitor, so I did not want to comment there. But that person had mentioned about the differences between correlation and covariance, and a pretty nice article, I will acknowledge that. So I had only clicked the like button. But if you are going to come across certain things like this, you may want to comment, thank you for the article, I also read something on similar lines. You may post some other link there, and if you have read an article, and you may also add up this with this, or I was of the impression. So if you can give a little detail, that shows that you are a kind of person who does due diligence towards your the work. That is something that you may want to work on. All right. So I cannot stress enough about the importance of social media, building your resume. All right. And I'm sorry, building your social media profile, building your LinkedIn profile, and extending it. All right. And if somebody were to look at the history of your social media or LinkedIn profile, they should be able to see the progression or the growth, your growth story, what you initially liked, and initially you were talking about the importance of statistics. Then subsequently you moved on to talk about modeling. Then you, in the last couple of weeks or days leading up to the thing interview, you're talking about the problems faced with the EDA, things like that. And those kind of things, if you are, it kind of shows your growth as a learner towards these analytics projects, and that is something that is very important. So it should look and feel that you are already a data scientist and you're extensively working in this particular space. So that is something that you may want to take up. And like I said, GitHub repository, Kaggle rankings, meetups groups. All right, meetup.com. If you go to meetup.com and generally contribute, so your digital footprint that you are creating, all right, is something that everybody is viewing now. Certain digital footprints you should be able to show. Now suppose, for instance, if you've contributed and, let us say, answered questions on Quora, then probably you may have to uh, respond to, you may want to tell out to the people that, okay, you know what, I responded to certain queries on Quora. These are my answers. This is the link. So if you are going to share a page, your 2-page resume, and in that half a page is all the links within that, imagine the kind of imagine the interviewer is going to be totally blown away. Every page, every link, one link clicks goes into the GitHub, one link tells you about your Kaggle, one link goes about your Quora, one link goes about your articles that you have posted within your LinkedIn profile, multiple articles that you have posted in your LinkedIn profile. So those kind of things are going to be amazing. If you are capable of investing in a small website, simple web presence website, let us say you know uh, ravikrishna.com or whatever that name, whatever your name is, www.ravikrishna.com, and if you can actually get some professional guy to put some you know a nice physical presence, and you can probably put your journey when you started the website and what all you did over a period of time. When you start putting it in order, that will definitely help you to achieve better connectivity and better mileage in your space. So that is something that you may want to also look at. This is a small suggestion, it is not mandatory. So you can probably simply mention your website. As anybody mentions, you can imagine, right? When you mention, please visit my website, everybody is going to definitely visit the website. And if your resume, if your details, if everything, what you are, your photograph, your travel, if you are a travel blogger, if you are having other interests, all right, if you have posted some YouTube video, all those links exist on that particular website, and you can probably from that location, you can like a repository, if you can go that, it's amazing, you are through. All right. uh, Big corporate organizations look for technically qualified people, but along with the technical qualification, they look for the lateral skills, they look for the communication skills, they look for the these kind of things. What is that different you're bringing to the table? All right. uh, how you can probably, are you a good photographer, are you a hiker? I mean, I can tell you, I don't want to take names at this point of time, but there are organizations which will hire you, and there are organizations, MNC organizations, international organizations with offices in Hyderabad, will hire you if you are good at kayaking, if you're good at sports, if you're good at public speaking, if you're good at playing the guitar, if you have these kind of skills, your resume will be on the top. Obviously, technically you have to be qualified, but they will probably downplay the requirement of the technical qualification. That's something that is you may want to look out. But again, these are things that you cannot fake. Now let me just give you a quick example. There was this person whose resume came to me, and he mentioned photography. All right, so what is your interest in that? Obviously somebody interests is photography, something like that they mentioned. So I asked him what is the camera that he owns, what model of camera he owns, and he was taken aback. Sir, no, I don't have any camera. And I asked him, how do you do photography? I use my mobile phone. We could make out that he wanted something to put, he didn't have anything, and therefore he decided to put photography. and he got caught. Now, it is okay to use your mobile phone, but be prepared for it. Rather than saying not having a camera because he was caught off guard, he was not even remembering that he had mentioned photography. The ideal response would be, I do like photography, but I don't really have. So whenever I go, I shoot from my mobile phone. I have this mobile phone which has got a pretty good resolution. I've uploaded my photograph in a particular thing. I'm a very private person. I have it in my cloud, and mostly I take photographs of nature, and I probably take zoomed up photographs, micro photographs, wherein I zoom up into bugs and things like that, and I try to do that. This is what is my favorite thing. Have been a much better response for the same thing that I don't have a camera, rather than saying I don't have a camera and leaving it at that. So be very clear. Interviewers are going to look at every single thing mentioned on your resume and going to question you on that. All right. So be prepared for that as well. And how do you prepare? All right. How do you prepare for the interview? Interview is, you are going to be selected for your technical capability. Um, right. You are going to be interviewed for your technical capability primarily, but you are going to be selected for your communication and other capabilities as well. So both are the things that is required. So the preparation time, very, very serious and straight consolidated preparation time is required. All right. 2 hours a minimum. If you're setting a target, set a 2 month to 3 month target, assuming that your requirements for your social media, your LinkedIn, etc., your activities on GitHub and all those things are already in place. After that, you are in place and you decide, give yourself a 2 to 3 month time and you start working on it. So use mind maps for quick reference. Our mind map, which is available on our website 360digitmg.com. All right, that in the website 360digitmg. You can see our logo on the top left of the screen. So if you go to that website, you'll be able to see the mind map, and that mind map is simply, I shouldn't say this, but it is quite amazing and quite comprehensive, wherein we have a lot of work has gone into it, and you can probably use that for your references. All right, so that is one thing. If you are a student of 360 digit MG, obviously you will be having the LMS access, and if you're having the LMS access, you will be having all the um, you know the recorded sessions. Go through those recorded sessions. Trust me, when you listen to a live session the first time, you think you've understood everything, but when you listen to it again, there are certain things that is left out. All right. So if you watch, if you are a fan, and if you watch a specific movie, all right, let us say you watch this movie Bahubali the first time, you understand, or you obviously, it is amazing when you watch it the first time. If you're a fan, I mean, I'm not trying to tell you you should watch Bahubali 10 times, but if you definitely like a movie, when you watch it probably the second or the third time, certain aspects of the movie will become clear. You may be concentrating your vision to the center of the screen, but on the sidelines of the screen, you'll be able to see certain other reactions. You will probably see in a serious scene, somebody was probably laughing or looking somewhere else. All right. So these are some of the things that you notice when you watch a movie second, third, fourth time. On similar lines, when you watch the recorded videos of the training, certain aspects of it will start to come out, and that is where you will get to know a lot more about the thing. So that is one thing. You have to necessarily spend good deal of time revisiting that. And unfortunately, while we do say that programming should not be an essential aspect, unfortunately, the skills, one of the skill areas that is being tested is the Python and R programming. So definitely brush up on them. All right. Most of the interviewers let you use the internet to get the program, get the answer. There are still people who are not up to the mark, but there are still people, and most of the people you look at, uh, they will say, okay, write a program or things like that and use the internet to do it. Otherwise, very rarely, 1 out of 100 probably will say, write it on a piece of paper, and how would you do that? So that's something that is rare. But again, if they are going to ask you to write a code on a piece of paper, they'll only ask you to write a small snippet of the code. They're not the entire thing, and that snippet they would expect you to, you know, um, uh, only a particular command or a small user-defined function, etc., something that they will expect. So these are some of the things that are there, and of course, there is cannot stress enough about the importance of research. All right, and uh, use refer the company website, refer the internet, try to look at their financial information. All right. Nowadays, it is all online interviews. All right, it is everything is either telephonic or on the web with the webcam on. So you may want to, have something written, something prepared, uh, and you can probably refer to that and give the responses. Okay, so this is basically what are the things it is there, and invariably an interviewer will have certain questions. We'll ask you at the end, do you have any questions? So if you are going to respond, no, it's okay, thank you. It shows your lack of preparedness. All right, have at least one or two questions specifically about the job role. All right, I have gone through your JD and I've applied for this, but these you can probably ask them questions like this particular profile. Will it be a usage for an internal customer that is within the organization? Is it a product driven approach, or is it a client based, or a product or a project in which I'll be working in? I'll be part of a team that will be developing a project. How many other people will be there in my team? What will be the workload? What will be the When I say workload, how much work I have to know? What will be the workload? Is what is the area of expertise that you're going to be specifically hiring? Will I have to do all the job, or will I be given a specific department? All those things you may want to ask them regarding your job. And one other thing to close it up is, generally this is something that you should be able to pull it off. Is there anything in my resume that you would like me to explain in more detail? All right, that is something that you may want to ask them towards the end. So with that, you should be good to go, and these are some of the things that really help you out. So that's what it is. So to wrap it up, understand the skills and interviews, get ready, build your digital presence, your digital footprint, start applying. All right, and the do's and don'ts that is mentioned here is predominantly for the face-to-face interviews in physical form, which does not exist. So, but nevertheless, now that we are having video calls, etc., so yes and no is a no. All right, obviously, a little more detailed answer is something that is required. So that is all I have to offer you at this point of time, and wish you the very best. All right, please do follow us on Facebook, on LinkedIn. Please do follow us, subscribe to our YouTube channel, etc., and keep looking for updates. Thank you so much.